Okay, I'm thinking that this function is not homogeneous, but let me think about it in the abstract. For an arbitrary scalar c, f of c times xy is f of cx cy. And I put, in place of y, I put cy then, cy plus 1 and cx. Okay, now if I, instead of multiplying the vector by the scalar first before putting into f, I do it later, then I have c times y plus 1x. Okay, that is cy plus c and cx. So the 1 there and the c there are different. Now, I can see that this is not going to work out, but what I need to do is show that there is a particular pair of things, a scalar and a vector, that doesn't work out. I can see that these things are different, but I need to still invent a particular pair that doesn't work out. Looks like I've done the 1, 2 as a fraction thing. Man, that is a deep muscle memory for me, isn't it? Okay, so there. 1, 2, again, an ugly 1. Sorry about that. All right, that is f of 3, 6. And that would be what? 6 plus 1 is 7 in the first slot, and the second slot we put 3. And I think my pen is dying here. And 3 times f of 1, 2, carefully not written as a fraction, is 3 times, let's see, 2 plus 1 is 3 in the first slot, and 1 goes in the second slot for a 6, 3. And yeah, so I see that the first component is different, 6, 7, 3 versus 6, 3. All right, give me a second to draw this. Okay, I got most of my drawing in here. I have x, which is 1, 2, 3 times that, which is 3, 6. 1, 2, 3, 4, 5, 6. Very good. And then I have f of cx, f of 3 times 1, 2. That's 7, 3, drawn at 7, 3. And then I have 3 times 3, 1. So this vector right here, f of x, that's 3, 1 right there. And I need to multiply that by 3. So 6, 3 would be right there. But that's not in line with this. I see. I made a mistake. 3 times 3 is not 6. It's 9. You know, brains are made out of jello and electrical storms, and they all make mistakes, especially arithmetic mistakes for some reason. But anyway, that should have been a 9, and let me give 2 more tick marks out here then. That's 8 and a 9. There we go. And in red, I'm going to draw a vector 9, 3, which is parallel to this vector because it is 3 times, or c times, that black vector, right? Points in the same direction, but f of cx doesn't. So that is to say, check it out. This is a weird idea, right? That multiplying the argument by a constant would somehow change the angle of the vector. Well, that's what lack of homogeneity looks like. When you multiply the argument by something, you don't. It's not the same thing as multiplying the output by something. This is a lovely picture of non-homogeneity.